We are doing part 2 of the graphing sine and cosine functions today. Okay, same goal from the last lesson. Okay, so it's pretty much just a continuation. You should skip the page for your 6-1 part 1 prep work, and then this should be on this page. There will be some handwritten notes at some point in time today, so just make sure that you plan accordingly. But we're going to start off with our foldable here. Some of this will be reviewed because we have talked about it. We have defined a lot of these terms like amplitude and period in the last lesson. Okay, so we're going to redefine them. We're going to continue to practice with them. But the main thing is we're basically working on continuing to graph these functions, this time more complex, more detailed functions. Okay, your homework is very simple. Y equals 2 sine x. Y equals cosine plus 2. Very simple, okay? We're going to work on expanding it, beefing it up a little bit. So, just to refresh your memory, y equals a sine bx plus c plus d. That is the general form that you guys wrote down on Tuesday when it came to graphing a sine, also cosine function. Okay? So, amplitude. We talked about what that is. Remember, amplitude is basically the height of your graph from a midline. It's always positive. Okay, that's hence the absolute value bars around the value of a, which is the number in the front. Okay, so if you have a graph of sine, which remember crosses through the y-axis at the origin, then goes up, down, and then back up. If you have 4 sine x, that means it's vertically stretched by a factor of 4, as you can see in the graph. And the amplitude in this case would be what? 4. Here, stretched again. The amplitude for the second one is 2. And this one, the last one, I told you, your amplitude is never negative. Okay, so your amplitude here will be what? 2. It'll be 2. That negative represents a what? The flip over which axis? Over the x-axis, okay? So as you can see here, if a is greater than 0, then the shape of sine is going to be stretched or condensed. Remember, it could also be 1/2 sine x, which means it's a vertical shrink or compression by 1/2. But again, if a is less than 0, it's a reflection over the x-axis. It's a reflection over the x-axis. A can never equal 0. If it does, 0 times anything is just, and then you wouldn't even have a function to begin with, okay? You'll have a constant. So, when you're looking at this, we're going to just determine the amplitude. We're not going to graph. You guys did your homework here, okay? We're just going to determine the amplitude, maybe describe the other transformations, and then we're going to continue forward. We need to get to the more hard stuff. For example, 1, what is the amplitude? 3. The amplitude is 3. So that means the graph was going to be vertically stretched by a factor of 3, which means its highest point would be what? 3. Its lowest point? 3. Very good. But number 2, what's the amplitude? 1/2. 1/2. But what did happen to the graph? It did shrink, but it also reflected over the x-axis, and we could draw that very easily, okay? Remember, amplitude affects which coordinate? Y. The y. How so? Like, what do we do to the y's? Multiply them. Very good. We also talked about a vertical stretch the other day. Okay, every graph is shifted vertically by d, so the number that's on the outside affects your y's as well. If d is greater than 0, we know it goes up. Less than 0, it goes down. And as you can see, that's already printed for you on your foldable, yes? Yes. The thicker line represents the transformed graph. Now, the second one, this example 4, you started with 3 sine x, and then you moved it down 4, okay? Multiplications always come before any additions or subtractions. So your stretching comes first before you ever move it up or down. Yes? Okay. So, describe to me what happened to the graph of sine in example 5? It went down 2. It went down 2. What about in example 6? After it flipped over what? The x-axis. So after it flipped over the x-axis, it went up 3. Okay? It went up 3. So for this particular one, in example 6, you would have to do what to your y's to get the new points? Multiply by what? -1, and then add 3. Very good. Okay? Questions on that? That was review from Tuesday. I was going to say yesterday. Tuesday. Now let's get to some more involved stuff, okay? Let's talk about the period. The period of a trigonometric function is the length of one full cycle of your graph. We talked about this a little bit on Tuesday. One cycle is basically the distance the graph goes before it starts to repeat itself. As you can see, the breakdown in the picture that's given to you, yes? Okay, so that's why for sine, also for cosine, the period is 2 pi because it's after that many radians when the graph starts to repeat itself. This formula right here is very important. Please make sure that you bold it, highlight it, do something so that you don't forget. Let's say the graph had been changed, it had been condensed, or it had been stretched, and you're trying to determine what the period is now of this new graph. You do 2 pi over the absolute value of b. So whatever number is beside our x in our trig function, that's the b that goes into this formula. Okay? So as you can see, it actually defined the period in example 7. The b, again, is the value that's right beside your x, right beside your variable. Then it's just 2 pi over the absolute value of that. That lets you know that the graph does one complete cycle between 0 and 2 pi over 3. Not 2 pi, but 2 pi over 3. If we take it with the transformations, that 3 represents a what?
A stretch.
Careful. It's on the inside. This time it's a horizontal by what? 1 over 3. So that means it's a shrink. So this graph gets compressed in. You might not be able to see it here. Maybe you'll see it a little bit better on your foldable. But this graph completes a full cycle not at 2 pi, but at 2 pi over 3. So it's a lot smaller. Okay? It's a lot smaller. Something else that's also helpful, and it'll be helpful for part 3, which we're going to do on Friday. That b tells you how many cycles occur between 0 and 2 pi. This number tells you how many cycles occurs between 0 and 2 pi. So if I were to continue this pattern, I would see 3 complete cycles between 0 and 2 pi of this graph. Okay? Questions on that? So, example 8. It says find the period of y equals 3 sine 1/2 x and sketch it. Okay? What's b in this problem? 1/2. So this is the period is going to be 2 pi over the absolute value of 1/2, which is just 1/2. I cannot leave it like that though. Keep change flip. That's 2 pi times 2 over 1. So my period is 4 pi. That 4 pi basically tells you that that graph is going to complete one full cycle between 0 and 4 pi. It's going to be 4 pi radians, which means this graph has been stretched horizontally by a factor of 2. The graph 3 sine x is stretched so that one cycle is completed in 4 pi radians. Okay? And there's the graph to help you. Well, actually, this is not the graph to help you. This is the graph of the original sine. Okay? How we would graph this? Horizontal stretches. Does that affect my x's or my y's? Horizontal, this affects your x's. How does it affect it? They end up getting multiplied. Just like how vertical stretches were multiplied, horizontal stretches and shrinks are also multiplied as well. But it's not multiplied by 1/2, it's multiplied by, 2. 1 over b. The same thing that we would normally use to describe the transformation is what we multiply our x values by. So because it's a horizontal stretch by 2, that means we're going to multiply all of our x's by 2. So what's 0 times 2? 2 pi, pi over 2 times 2. Pi. What's 2 times pi? 3 pi over 2 times 2. That's 3 pi. And what's 2 pi times 2? So those are going to be the x's that we plot. The y's, though, does anything happen to the y's? No. Well, actually, if something does actually happen. What happens for this? They get what? Multiplied by 3. So any vertical stretching gets multiplied by 3. So that's 0, 3, 0, -3, 0. The blue are my points that I plot. So that's 0, 0, pi 3, 2 pi 0, 3 pi -3, and 4 pi 0. So not only is it a vertical stretch, it's a horizontal stretch as well. Since B was 1/2, that little extra note that I put on the other slide lets you know that half of one cycle occurs between 0 and 2 pi. When I look between 0 and 2 pi, the blue line, isn't that half of one cycle? So it lets you know how many cycles occur between 0 and 2 pi, half of a cycle. Okay. Let's look at this one. We need to find the period of y equals sine 2x. What's the formula to find the period? What's the absolute value of b? 2. So what's 2 pi over 2? Pi. So my period for this particular trig function is pi. That lets me know that I'll complete one full cycle between 0 and pi. Okay? How many cycles of the function are completed between 0 and 2 pi, though? 2. Because it's the value of b. B tells you how many cycles are completed between 0 and 2 pi. So, for this problem, what am I going to do to all of my x's?
Or divide by 2.
I'm technically going to, if I multiply, what am I multiplying it by? 1/2, which is technically dividing by 2. Okay? So, for the pink, is it okay if I put it just right beside in a different color, or do you want me to redo the chart altogether? Okay. So I'm going to multiply all of my x's by 1/2. What's 0 times 1/2? What's 1/2 times 1/2? A quarter.
Yeah.
So that's, how would you write that as a fraction? Pi over 4. And if you're confused, all I'm doing is this: 1/2 times pi over 2. Multiply straight across. That's pi over 4. What's 1/2 times pi? Pi over 2. What is 1/2 times 3 pi over 2? A little louder. 3 pi over 4. So I'm just multiplying straight across. And what's 2 pi times 1/2? Just the pi. Okay? Did I vertically stretch it at all? No. So all the original y's stay the same. So that's 0, 0, pi over 4, 1. Pi over 4 is halfway in between 0 and pi over 2. Pi over 2, 0. 3 pi over 4 is halfway between pi over 2 and pi. And then pi 0. That is one cycle. But it asked me to sketch it to 2 pi. So what do I need to do? need to repeat the cycle. I know I need to go up to 1, but where is it going to be? In between pi and 3 pi over 2. Think about your unit circle. Here's pi, here's 3 pi over 2. 1, 2, 3. What's that one in the middle? The angle.
Oh, sorry.
210.
225.
Okay, I need as a radian.
Oh.
Wait, which one are we talking about?
Oh,
The one in the middle.
Oh.
5 pi over
4.
4. There we go. Okay? Then I need to be at 0, but where am I going to be at 0? What angle? I go up to 1, then I have to come back down to 0. Where? Three pi over 2. Good. Then I'm going to be down in -1. Seven pi over 4. And then I'm going to be up at 0 where? 2 pi. Pattern. 4, 0. 1 4, 2 4s, 3 4s, 4 4s, 5 4s, 6 4s, 7 4s, 8 4s. And there you go. Questions on the period? Handwriting this into your notebook. So your horizontal transformations also affect the frequency of a function, okay? Frequency, definition, is the number of cycles the function completes in a 1-unit interval. I'm not talking about a 1 radian. I'm talking about just a 1-unit interval, okay? To find the frequency is just the reciprocal of the period. So whatever the period is, you just flip it, okay? So for those who maybe plan to go into physics or anything around those lines, you know, you deal with frequencies, sound waves for you musicians out there, you know, music models a circular function, a sinusoidal function. So it's close to home. Okay? Those who like creating music, like beats and things like that, you look at sound waves and things, frequency waves, you're looking at sinusoidal functions. So, I mean, it's very straightforward, okay? That's very straightforward. So if they ever ask you to find the frequency of a particular function, you probably more than likely found the period of some time, you just do the reciprocal and that's it. Phase shift, the one I hate the most, okay? Because that's what deals with the moving to the left or to the right, okay? So it's the horizontal shift of the graph from the left endpoint. It is determined by the general equation above and equals negative c over b. That is a negative c over b. So whatever c is, you negate it and you divide it by the b value. So in example 10 where it says find the phase shift for y equals 2 sine 3x minus pi and graph one cycle of the function, you do have a phase shift here. In other words, you do have a moving to the left or to the right. So you do negative c. So c in this case is a negative pi. Everybody see that? You divide it by b. b is 3. So a negative and negative make a positive. So that's pi over 3. So this graph shifts to the right pi over 3 units. Okay? It doesn't shift to the right pi units. It shifts to the right pi over 3 units. Okay? And this is the graph for that with the vertical stretch of 2 and a period of 2 pi over 3. Okay? There's no table there, but that's all together. We're going to do some ourselves, as you guys can see. So that one problem from your homework that was x over 3 plus pi over 3, pi over 2. Okay? You guys were right to say it was a horizontal stretch by a factor of 3, but now knowing this, it moves to the left how many units? What's C? So there's going to be a negative pi over 2 because it's negative c all over what's b. You don't include the x's, it's just the b, so 1/3. You can't leave it like this. What do you have to do? So negative pi over 2 times 3 over 1. So you move to the left 3 pi over 2 units for that particular one. So I was like, I'll address it in this lesson. So that's how you do it. Okay, that's how you do those. All right. We're going to find the phase shift of this particular problem. Y equals negative 3 sine x plus pi over 2, and then we're going to graph one cycle of the function. Okay? Let's find the phase shift because there definitely is one. Negative c over b. What's c in this problem? So I have a negative pi over 2. What's b? 1. So what's my phase shift? Okay. That negative pi over 2 lets you know the graph is going to be shifted to the, which direction? No. Left. Shift, oh, sorry. Do it right. Shifted pi over 2 units to the left. Okay? That minus pi over 2 is basically what you would do to your table to get those values. That phase shift, that value you get is what you actually apply to your x's to get the phase shift. Okay? But the rule still applies. Whatever this symbol is, you do the opposite of it. Okay? So, this affects your x. Phase shifts affect your x. By either addition or subtraction. If I have a horizontal stretch, I apply that first, and then I apply my phase shift. But since I don't have a horizontal stretch or shrink, I'm going to basically take all my x values and subtract pi over 2 from them. Okay? This is where being good with your common denominators comes into play. Okay? What's 0 minus pi over 2? That one's an easy one. What's pi over 2 minus pi over 2? That's another easy one. What's pi minus pi over 2? Is pi over 2. You hesitated. I'll test and make sure. What's 3 pi over 2 minus pi over 2? It's technically 2 pi over 2, which is just pi. And then what's 2 pi minus pi over 2? If you've been confused, how are we getting those numbers? We are literally subtracting every x value by pi over 2. In order to subtract this, I need a common denominator, so this turns into 4 pi over 2, and that's how we got 3 pi over 2. What's happening to my y's to graph this? I multiply by 3 only. It's negative 3. Okay? So when I multiply by the negative 3, it's going to actually take care of the flipping for me. And what you see in the pink are the points that I graph, and I'm doing one cycle. Negative pi over 2, negative 3, 0, negative pi over 2, 0, 0, negative 3, pi over 2, 0, pi 3, and 3 pi over 2, 0. There's the reflection. It goes down instead of up first. It has its vertical stretch by a factor of 3, and it's been shifted to the left pi over 2 units. Now this, I probably will never ask you what is the right endpoint and what's the left endpoint of one cycle. I will never ask you that. However, if you are unsure about the values you get, okay, you can always use this formula right here to see, okay, for one cycle, like once you set up that equation and solve it, it should start at whatever this value is, and it should end at whatever this value is. It's more of like a check to make sure that, okay, I did my math right. Okay? So whatever that bx plus c is, if you set up a compound inequality between 0 and 2 pi and basically solve, you'll know where your furthest left endpoint should be and where your furthest right endpoint should be. And it's very simple when you're doing compound inequalities. All you do is add or subtract. That's how they got pi less than or equal to 3x less than or equal to 3 pi. And then divided everything by 3. So for this particular equation that was horizontally stretched by a factor of 1/3 and then had a phase shift of what number? What's the phase shift here? What's the formula for phase shift? What's C? Negative pi. What's B? A negative make a. So it was shifted to the right, pi over 3 units. It was horizontally stretched by a factor of 1/3. So the graph should start at pi over 3 and end at pi. If you were to do the table, this would be your first value and your last value of the table. Okay? I'm not going to ask you, though, what's the left endpoint? What's the right? I'm not going to do that. But this is more so just of a check to see if you are doing your math correctly. Okay? So let's just practice with this particular one. Again, you would take that bx plus c, which is 1/2 x plus pi over 2, and you would set it up in a compound inequality between 0 and 2 pi. How do I solve for x?
Subtract pi over 2 both sides.
So this is negative pi over 2 less than or equal to 1/2 x less than or equal to what?
3 pi over 2.
How do I solve for x? I will be dividing by 1/2, which is the same thing as multiplying by 2. So if I multiply everything by 2, what's the left side? What's negative 1/2 times 2? And what about 3 pi over 2 times 2? So my furthest left point would be negative pi. My furthest right point would be 3 pi. And again, those would be the same things you would get if you were to do this in your table. Okay? You would apply your horizontal stretch, then your phase shift to your x's. Right? Questions? One thing I want you to be aware of, especially when it comes to phase shift, is how it's written. What you see here in this font, you have y equals sine x, sine bx plus c inside the parentheses. Same thing with cosine. On that second line, though, you have the b outside of the parentheses. There is a big difference here. If you distribute it through, you'll get the you'll basically, well, the thing is that when it's written like the second line, this value that's inside the parentheses is your phase shift. Okay? When the b is factored out, that number inside parentheses is your phase shift. There will be no need to do negative c over b when the b is already factored out. When the b is not factored out, like in the first set of equations, you have to do negative c over b to find your phase shift. Okay? So when you get an equation and you're trying to describe the transformations, you're getting ready to graph, just be aware of that. Okay? If the b is already factored out, and you'll know there'll be a number on the outside of the parenthesis, then the number inside is your phase shift. So just to kind of show you the differences, okay? Let's look at this equation, Okay, we're not going to do anything. We're not going to graph it. I just want to just go over it with you. Y equals sine 3 parenthesis x minus pi over 3.
Pi over 3 is the phase shift.
So that pi over 3 is the phase shift, and we're heading which direction, left or right?
Right.
We're heading to the right, okay? What about this one? To the right, because the 2 is already, the b is factored out. There's a number on the outside of parentheses. That's what I was talking about. But when you look at something like this, you either can factor out b and then try to figure out what the c is, or you can do negative c over b to get your phase shift. Okay? So there's a difference between all of these. There's a difference between all of these, okay? So what we're going to do is so let's look at this last example on your last slab. All of these rules that we've talked about for phase shift and period and amplitude and vertical shift, they apply to cosine as well. Okay, they literally are the exact same thing. They just start at different places. So whatever we did for sine applies to cosine. We just got to make sure that the y's, they're not 0, 1, 0, negative 1, 0. They start with the 1. So let's do this. Let's put everything together. Let's graph this function. Okay? What's the amplitude?
3.
It is 3. Remember, it's the absolute value of A. A is 3, so you take the absolute value of it. The period. What's the formula to find the period?
2 pi over b.
All right, B is already positive, so it's 2 pi over 1/2. What is that? 4 pi. That lets me know that I'll complete one full cycle between 0 and 4, or within 4 pi radians, okay? And I will have half of one cycle between 0 and 2 pi, okay? My phase shift. The formula is negative c over b. What's c? Negative pi over 2. What's b? 1/2. 2 negatives make a positive, okay? And what I have to do to this? Keep, change, flip. What is that? 2 pi over 2, which is just pi. So my phase shift is pi. I am moving to the right pi units. And my endpoints, this is the foldable, it all went together, okay? So if I do the little formula to figure out, okay, exactly where is my one cycle that I'm graphing going to start and where it's going to end, aka the first entry in my table and the last entry in my table, how do I solve? Add pi over 2. So I have pi over 2 less than or equal to 1/2 x less than or equal to 5 pi over 2. So I don't want to say anything. Multiply everything by 2 to get rid of that 1/2. What is that? Pi. And so my graph's going to start at pi and end at 5 pi. Hence why it was so long. And if you look, how far apart are 5 pi and pi? 4 pi of the period, right? As it should be. Okay? So let's make my table. Let's figure out what's happening to my x's and what's happening to my y's. What am I going to do to my y's? Let's start there. Those are always the easiest. Multiply by 3 because that's the amplitude. Am I going to add anything to it? The y's? No. What am I doing to my x's? Multiplying them by? It's 1 over b. 1 over b. So it's going to be multiplied by what? 2. And then I'm going to add pi after that. Because that's my phase shift. That's what's happening to my x's and my y's. Remember, guys, when it comes to that horizontal, stretch or shrink is always 1 over the value of b. So my x is 0, pi over 2, pi, 3 pi over 2, and 2 pi. I'm going to multiply each of those by 2, and then add pi. So let's multiply by 2 first. Was 0 times 2? Pi over 2 times 2? Pi times 2? 3 pi over 2 times 2? And the last one? So that was the multiplying by 2. Now I'm going to add pi. Was 0 plus pi? Pi plus pi. 2 pi plus pi. Help me keep going. Like I said, the first entry and the last entry. Now this is a cosine function, which means my original y's start at 1. 1. And every single one of those is getting multiplied by 3. So that's 3, 0, and what you see in the green are the points of this function. And voila. That's how you apply all the transformations, multiple ones at one time. So let's summarize what we've talked about. Okay, you guys have this written down at some point in time already. Okay, when you have a graph of y equals a sine bx plus c plus d, or cosine, where a does not equal 0 and b does not equal 0, the amplitude is always the absolute value of a. The vertical shift is always d. Your phase shift is negative c over b, and it is the absolute value of b. We probably won't give you any y-axis reflections, but there you go. The period is 2 pi over the absolute value of b. Your frequency is the absolute value of b over 2 pi. You know you have this written down already. You know that, right? I'm just summarizing in one little page. Okay? The one thing that I suggest that you do write down that we haven't written down is this one right here. That the midline is y equals d. Remember how I was talking about the amplitude is the distance between the highest point and that line in the middle? That midline is whatever the d is. So whatever that vertical shift is, y equals d is that midline. Something else I suggest that you write down. Remember, your x and your y coordinates. When I have an amplitude, does that affect my x's or my y's? And am I multiplying or adding them? So whatever my amplitude is, I'm going to multiply my amplitude by. Whatever my amplitude is, I'm going to multiply my y's by them. What else affects my y's? Which one of these pieces? So after I've applied my amplitude, then I'm going to either add or subtract that vertical shift. What affects my x's? The phase shift, and what else? The period. Well, it's technically not the period, but it's the value of b. So when it comes to my x's, you multiply by 1 over b first, and then you're either going to add or subtract your phase shift. If you have multiple transformations in one and you're asked to graph, that's how your x's and your y's are affected. If anything was in the green, the box, and then what I wrote on the side, that's the most important thing. Because you already have everything else written down. And that is truly how you graph sine and cosine trig functions. All of these, minus just tiny little changes, are also how you graph the other ones. But that'll be for after break.